Welcome to the Explainer. You know, have you ever stopped to think about how massive apps, the ones that handle millions of users, how do they keep all that data straight without it just becoming a complete mess? Well, the secret isn't magic. It's a solid blueprint. And today, we're going to learn how to draw that exact blueprint, turning a chaotic idea into a really clean, powerful database. Okay, so here's our game plan. We'll kick things off with why we even need a blueprint in the first place. Then we'll get into the building blocks of that plan, the basic language. After that, we'll cover the rules of the road, and then the really cool part, turning that blueprint into actual tables. And we'll finish up with a special case you'll definitely see out in the wild. All right, first up, why even bother with a blueprint? To really get why a good design is so crucial, you gotta see the chaos it prevents. So let's start with the old school way of doing things. Just, throwing data into a bunch of simple files and see exactly what kind of problems we're trying to fix. Okay, this slide really lays it all out. On the left, you've got the classic file system mess. Think of it like a desk just covered in sticky notes. Data is copied all over the place, so if you change an address on one note, it's still wrong on 5 others. It's a nightmare to find anything, and security, forget about it. But on the right, that's the solution. A database management system, or DBMS. This is like having a super organized, hyper-efficient librarian who knows where everything is, makes sure all the copies are consistent, and keeps everything under lock and key. So how do we get from that chaotic desk of sticky notes to the organized library? Well, you can't just dive in and start building. You absolutely need a plan. And in the database world, that master plan, that architectural blueprint we keep talking about, it's called the entity relationship model. You'll usually just hear it called the ER model. Okay, so every blueprint has its own language, right? Its own symbols and rules. The ER model is no different. So let's break down its 3 core building blocks. You can think of them as the nouns, the adjectives, and the verbs of our database grammar. First up are the nouns of our language. Entities. An entity is just a thing we wanted to keep track of. Simple as that. It could be a person, like a student or an employee, a place, or even a concept, like a project. In our diagrams, we'll draw it as a plain old rectangle. But, just having a box that says employee isn't very useful, right? We need the details, and that's where attributes come in. These are the properties, the characteristics, basically the adjectives that describe our noun. Things like name, salary, or date of birth for that employee. And what's cool is that attributes themselves can get kind of interesting. They're not all the same. For example, you can have a simple one, like first name, or you could have a composite one, like address, which is really made up of smaller parts, like street, city, and state. You can also have single-valued attributes, like your age, you only have one, or multi-valued ones, like phone numbers, because you might have a few. And finally, some are stored, like your birthday, while others are derived, meaning we can calculate them, like figuring out your current age from that birthday. And that brings us to our third piece, relationships. So if entities are the nouns and attributes are the adjectives, then relationships are the verbs. They're the action words that connect everything together, showing how one entity interacts with another. An employee works on a project. That works on part, that's the relationship, and we draw it as a diamond. Okay, so we have our basic vocabulary now. Entities, attributes, relationships. The nouns, adjectives, and verbs. Now it's time to learn the grammar. These are the really important rules that control how all these pieces fit together. So the first big rule is called cardinality. And honestly, it's all about one simple question. How many? We're talking about the maximum number. For any 2 things that are related, can one of them be linked to just one of the other? Or can it be linked to many? And that question gives us the 2 most common types of relationships you'll see. First, there's one-to-many. Think about it. One department can have many employees, right? But each employee typically works in only one department. Then you have many-to-many. This is where the connection goes both ways. An employee can work on many different projects, and at the same time, a single project can have many employees working on it. All right, our second big rule is participation, and it's the flip side of the coin. If cardinality was about the maximum number, participation is all about the minimum. It asks a really critical question. Is this relationship optional, or is it mandatory? Does it have to exist? And this creates a really powerful distinction. On one hand, you have partial participation. That just means it's optional. For instance, an employee can exist just fine without being a manager. Not every employee is a manager. But on the other hand, you have total participation. This is mandatory, and we show it with a double line on our diagrams. For example, We might decide that every single department must have a manager. A department can't even exist in our system without one. Okay, this is where the rubber meets the road. We've drawn up our abstract blueprint. We've defined all the rules. Now for the most important part. How do we take that design and turn it into actual real-life database tables that can hold our data? So yeah, how do we translate these drawings of boxes and diamonds into a real working database? Well, it's not magic. It's actually a pretty straightforward process once you know the rules. Let's start with the one that usually seems like the trickiest, a many-to-many relationship. A perfect example is our employees work on projects scenario. And here's the golden rule. You can just burn this into your brain. For a many-to-many relationship, you will always need 3 tables. No exceptions. It's that simple. So what are those 3 tables? Well, it's pretty logical. You get 1 table for employees and 1 for projects. Easy enough. Each of those tables has something called a primary key. Think of it as a unique ID for every single employee or project. But the real magic is that 3rd table in the middle, often called a linking or junction table. Here we're calling it works on. Its only job is to connect the other 2. It does this by holding the IDs from both tables. When a key from one table shows up in another, we call it a foreign key. This 3-table structure is how you make that many-to-many connection work perfectly. Okay, so that's the many-to-many case. Now let's look at something a little simpler, and honestly a lot more common, the one-to-many relationship. Again, think department and its employees. Now in this case, we get to be more efficient. We don't need that 3rd table in the middle. For one-to-many, you only need 2 tables. That's it. So how does that work? The trick is actually really clever and simple. You just take the primary key from the one side of the relationship, in this case the department ID, and you add it as a new column over on the many side in the employee table. That new column in the employee table becomes a foreign key, pointing back to the department that employee belongs to. It creates that link perfectly, no extra table needed. All right, let's wrap this up by looking at one last, kind of special case. This is something you'll definitely run into. We're talking about an entity that's so dependent on another one that it can't even stand on its own. This is called a weak entity, and the classic example is an employee's dependence. Think about it. If you have a dependent named Jane, there might be lots of Janes in the company. The name alone isn't unique. To know which Jane we're talking about, you have to know which employee she's a dependent of. She can't be identified without her owner. And that means her participation is always total. You can't have a dependent floating around without an employee they belong to. The rule for converting this is simple. The weak entity gets its own table, and that table must include the primary key from its owner, the employee ID in this case, as part of its own key. So let's just pull it all together. This whole blueprinting process, making an ER model, it's not just some academic thing you do. It is the absolute bedrock of a good, reliable database. Taking the time to do this up front is how you stop data from getting copied all over the place. It's how you make sure your data actually makes sense. And it's how you build a system that you can trust, one that won't fall apart as it gets bigger. You know, this design process we've just walked through, it's the hidden engine behind basically every app you use every day. Social media, online stores, you name it. They all started with a blueprint just like this. So the real question is, what problem are you going to solve with the next blueprint you design?